Hi, my name is Yania. Today we are presenting our Discrete Structures project, modeling SQL injection attack paths using graph theory and probability. Almost every company today relies on databases, which make them a prime target for cyber attacks. SQL injection or SQLI is the most well-known attack path against them. It is not a single move. Attackers scan for vulnerable sites, plant malicious SQL, exploit authentication, and then attack the database step by step. This multi-step nature is exactly why these attacks are so hard for security teams to detect and respond to. Our core idea is that this attack process can actually be predicted mathematically. We modeled it as a directed graph where nodes represent system components or attack stages and edges represent the transitions between them, each carrying a weight based on time, skill, or resources required. Using an algorithm like Dijkstra's, security teams can find the attacker's lowest resistance path to the database and prioritize the defenses accordingly. Next, my groupmate will walk you through how graph theory was used in this project.
Graph theory studies connection between objects writing formula as G equals V, E, where V is a set of the vertices and E a set of the edges. In our project, each of the 20 SQL injection entities in our dataset became one vertex. So V has 20 elements. We drop an edge between two vertices whenever these two attacks share the same attack type. So, for example, every blind SQL injection payload clustered together. The group of the attacks by explosion techniques, so analysis can visually spot attack families at a glance. To confirm we built a graph correctly, we run worked example. Take 3 payloads from the blind SQLi group, V3, V8, and V15. Since all of share the same attack type, every pair connects, given 3 edges, and each vertex had a degree of 2. The handshaking lemma states that the sum of the degrees equals divides at the number of the edges. 2 plus 2 plus 2 equals to 6, and 2 times 3 also equal to 6. Both sides match as the graph checkout.
So alongside graph theory, we use probability to measure how often certain attack characteristics show up. So we use the relative frequency formula P of A equals F over N, frequency over total observations, since we are estimating from real attack data rather than assuming equally likely outcomes. In our datasets of 20 payloads, 12 are high severity, 6 medium, and 2 low. So P of 5 equals 12 over 20 or 60%. 3 out of every 5 payloads we study are high severity. So we also look at specific attack types. Only 3 of the 20 payloads are union-based, giving P of union equals 15%. But here where it gets interesting. Using conditional probability, we ask, given that an attack is union-based, so how likely is it also high severity? 2 of those 3 unions attacks are high severity, so P of 5 given union equals 2/3. It's about 66.7%, well above our 60% baseline. That tells us union-based attacks are disproportionately dangerous. So now Steve will show what happens when we apply this to an actual network.
For our findings, we've modeled a small network as a directed graph. Each device a vertex, each connection a directed edge, running from an employee laptop through the web server and application server down to the database backup servers. Through using the transitive property of relations, we uncover 5 indirect attack paths. For example, the laptop isn't directly connected to the database, but it can still reach through the web and application servers. This gave us 2 big insights. The application server is one of our most critical nodes, since compromising it opened access to both database and backup server. And because of the database is reachable through 2 separate routes, blocking one path isn't just enough. The whole network needs to be secure, not just one connection. Our takeaway: SQL injection attacks aren't just random. They follow patterns that discrete structure can map and predict. Graph theory model the discrete connections probability, quantify the risks. The relations reveal hidden threats. Next step would be using tests on a larger real-world dataset.